is Tommy, and as Chris said, I'm here to talk about the role of vegetation change in restoring a bighorn sheep population to the Pusch Ridge Wilderness area. To give a brief overview of where this presentation is headed, to give you an introduction to the study area and the history of bighorn sheep in southern Arizona, talk about the data and the data sources that I used. From there, we'll go into my methods and results. Finally, I'll reveal my conclusion. So this story starts in the 1850s. As settlers began to arrive to the Arizona territory, the bighorn sheep population began to drastically decline. This was due to unabated hunting by miners and railroad workers, disease introduced by domesticated livestock as settlers moved west, and also restriction to natural water sources. This decline began to continue until 1999, when the final Arizona Game and Fish Department survey found 0 sheep in the area. Here we are today, 2013, November 18th. 31 bighorn sheep were reintroduced to the Pusch Ridge Wilderness area. Citing natural habitat changes due to wildfires, this is how they justified reintroducing the sheep. So I'm going to investigate the vegetation change for the years from the time they were last surveyed to now. Pusch Ridge Wilderness area is bordered by Oro Valley to the west, the community of the Catalina foothills to the south, and wilderness to the north. The wilderness area was established in 1978 due to the Endangered American Wilderness Act. 56,430 acres were set aside in the Santa Catalina Mountains. This area was chosen as it has historically held the largest sheep populations, and it also is comprised of steep and rocky terrain. The primary management focus in this area was restoring access to water sources. The data that I used was all projected in the WGS 84 UTM Zone 12. I chose this projection as this is what the Landsat images were projected in, and in future analysis I'm using cell count, so I didn't want to alter the projection in any way. From the United States Geological Survey Earth Explorer website, I downloaded Landsat thematic 4 to 5 data. I chose to use the climate data record as it was already atmospherically corrected. Choosing this data set limited the scope of my study as no atmospherically corrected data was available after 2010. The United States Forest Service provided me with a shapefile of historic fires which occurred in the Santa Catalina Mountains from 1929 to 2012. This will be used in future statistical analysis as well as identifying fires that burned within this boundary from 1999 to 2010. The Arizona Game and Fish Department provided me with the shapefiles for the habitat areas as well as the wilderness area. And in the maps that I represent my analysis in, I use the Esri base maps. So to get started, I had to identify escape terrain. Escape terrain is defined as a slope of 60 degrees or greater. To do this, I used a 30 meter digital elevation model as an input in the slope analysis tool. This created a raster with outputs with values from 0 to 81 degrees. In order to select the slopes that were identifiable for escape terrain, I created a conditional statement in the raster calculator. What this statement does is create an output raster of 2 values, 10 and 1. A value of 10 indicates that the slope is suitable as escape terrain. A value of 1 indicates that the slope is not suitable as escape terrain. A simple SQL statement isolated the values of 10, and from there I used the raster to polygon tool and created a vector layer. Next, I used the feature to point tool to create the points layer, and this is a layer that I use as input in the buffer tool to create a 400 meter buffer, which these buffers are what I'll be using to assess vegetation change and accessibility to escape terrain. My slope analysis identified 68 points within the Pusch Ridge Wilderness area that are suitable as escape terrain. As you can see, the high density of slopes is in the western half of the habitat, the low density of slopes occurring within the fire boundary. This was my first indication that the fire might not have improved that much sheep habitat. Next, I wanted to assess the burn severity. As Marla mentioned, I used the normalized burn ratio. This is a differencing of the mid and near infrared bands. And when you subtract the pre-fire MBR from the post-fire MBR from the pre-fire MBR, you create a differenced MBR. Here's a map showing the burn severity within the bighorn sheep habitat. This data, the burn severity data that I'm using to represent this, was obtained from the MTSB data set, and I chose to use their data as they use a more robust model that includes variables for monitoring multiple years after the fire, as well as data collected at the site of the fire. So we have values of low severity, moderate low severity, moderate high severity, and high severity. I had to make it a little transparent so you could see where the bighorn escape terrain within the path of the fire occurred. But there were 10 slopes that occurred where the fire burned, and as you can see, the 2 in the middle were the ones that occurred the most severe burns, with the remaining 8 incurring low severity to moderate low severity. This is my second indication that maybe the habitat really hasn't been that altered. So to further assess vegetation change, I decided to use the Normalized Difference Vegetation Index. Again, I'm using the years 1999 to 2010 as the data set I chose, limited this. There's no atmospherically corrected data for my study area available after 2010. This is similar to the NBR, but this is differencing the near infrared band and the red band. When you subtract the post NDVI from the pre-NDVI, previous NDVI, you get a highlight change image. This image could contain values from 1 to -1. The closer to a whole number, the more vegetation change that occurred. Here we have values from roughly -0.5 to +0.5, which indicates that, well, there's some change, but maybe it wasn't the most change. We overlay the buffer zones. You can see the lightest colored pixels are where the greatest decrease in vegetation occurred. The darkest pixels indicate little vegetation occurred. And in the slopes in the eastern and the northwestern part, you can tell that there's a mixture of light and dark pixels. I was interested in quantifying this change, so I ran the ERDOS change detection tool, which goes pixel by pixel and tells you the percentage of change that occurred within each pixel. I chose a 10% threshold, as this threshold showed the greatest variance. I did create change detection for 5% to 25%, but again, the 10% showed the most variance, so this is what I went with. Being interested in accessibility to escape terrain, I used the masked raster tool and basically clipped the areas that had a decrease or increase greater than 10% to my buffer areas. As you can see, the slopes in the middle of the burn boundary incurred the largest decrease greater than 10%. Again, you can see there's a mixture of red and blue, but it doesn't look like much. This was kind of the nail in the coffin, that maybe not that much change has occurred in this habitat. To further quantify, I took the total number of cells in the habitat, and I divided the 3 categories that I was interested in by that to get a percentage. Within the Pusch Ridge Wilderness area as a whole, the greatest variance was a decrease, and that was about roughly 15.5%. About 2.5% increase in vegetation, and roughly 82% remained unchanged. Within the buffer areas I was interested in, the story is a little different. The greatest variance was an increase in vegetation of roughly 9%, a decrease of 7%, and about 84% remained unchanged. Now, having these percent change maps, I could tell that, well, the habitat hasn't really changed, and I had these historical records from the U.S. Forest Service with historical fires, and from Game and Fish I had sheep surveys going back to the 1960s, so I thought it would be interesting to assess the relationship between acres burned and the sheep population the following year. Here's a simple bar graph I made. You can see the distribution for years of sheep population for years following a fire. It's not a normal distribution. This is why I used Pearson's one-tailed correlation test. I ran this through IBM SPSS statistical software, and the output table is here. The Pearson correlation is a weak correlation with a value of negative 0.120, and the significance, also known as the p-value, is 0.307. This indicates that there is not a strong enough correlation to do any further statistical analysis. So my statistical analysis stopped here. Now there are some reasons why these results might be skewed. One of those reasons is the survey methods changed multiple times in this time period. I think 8 different times their survey methods changed. And anytime you have inconsistencies in survey methods, there's going to be kind of skewed. You have to suspect any statistical analysis that's derived from suspect data. So areas of future analysis, bighorn sheep don't know what an imaginary polygon is. They're going to go wherever they feel safest, wherever there's food, wherever there's water sources. So I'd like to perform this analysis for the entire Santa Catalina mountain range in addition to the neighboring Tortolina mountain range. I'd also like to perform a supervised classification of Landsat imagery to assess change of individual vegetation species. Some species of bushes are taller than others, you have trees, and basically what Game and Fish Department said is there's a decrease in low-lying vegetation which would allow the bighorn sheep to elude their predators and increase their eyesight. So it'd be interesting to see what types of vegetation did incur these increases greater than 10% and decreases greater than 10%. So in conclusion, the greatest variance, plus or minus 10%, was within the 400-meter buffer was an increase in vegetation. And this indicates that accessibility has not improved since the bighorn sheep were last surveyed in the late 1990s. Again, here's my percent change table, just to reiterate that. And with 84% unchanged, an increase of roughly 9% and a decrease of 7%, I don't think that the Game and Fish Department really assessed the vegetation change wisely before reintroducing the sheep. Thank you for your time, and at this point I'll be ready to answer any of your questions.